good afternoon, good evening, or good morning, depending on when you are watching. So this is BT205 Fluid Mechanics Practical. This is the BT205 Fluid Mechanics Practical. We're going to be dealing with introduction with fluid mechanics. So we're going to be covering mostly fluid properties, the likes of density, specific gravity, specific weight, specific volume, and so on. So that's what we're going to be dealing with mainly. So before that, let's just run through some basics of introduction. So like you know the meaning of fluid mechanics. What's the meaning of fluid mechanics? It's the study of the fluids, either liquid or gases, are under the influence of the forces. You are studying fluids and you are studying the forces that will act on them. So that's just it. Then we have fluid statics, fluid dynamics, and fluid kinematics. Those are just the beginning part of fluid mechanics. So mainly we are going to be looking at the fluid properties. So understanding the density. The first one is density. When we are talking about density is a derived quantity. It's defined as mass over volume. So when we are asked to look for density, just get the mass, get the volume, and get the answer. But you can also get it in another way. So let's continue first. Second property we are going to be looking at is specific weight. So specific weight. Specific weight. What specific weight is defined as the weight per unit volume of a substance, of a fluid. The weight per unit volume. And what is weight? Just W per unit volume. So that's weight over volume. And we all know that W is equals to what? Mg. That's the mass multiplied by what? Gravity. So you can just put that here and you have mg over v. You can agree with me that you can also pick your density from here because you already have m over v here. So you can also say that specific weight w is equals to m over v then g. For more clarity, you can also say that this is what? Rho g. So w is equals to what? Rho g. So you can also look for density from here because sometimes they can give you mass and volume, sometimes they cannot give you, they just give you the specific weight and the gravity. So when you want to solve your density, you can just bring it back here and you have the weight over the gravity as solved for your density. So another one is specific volume. Specific volume. So what's specific volume? V. It is the inverse of density. That means it's V over M, volume over mass. So you can also say it's what? 1 over density, since it is the inverse. So that's just for that. And what do I have again? We have specific gravity also. Specific gravity. So specific gravity is the ratio of density of substance over the density of water, which can be also said to be density of substance over 1000. So that is just the basic part of this basic part of the. So now let's calculate the specific weight, density, and specific gravity of 1 liter of a liquid, which weighs 7 Newton rather. So let us pick out the given. What were we given? We are given volume as 1 liter, which is also equals to 0.001 liter square. That's the volume. Then we are also given weight. We are given weight as 7 Newton. So and you have to look for what? Specific weight. From here we know that specific weight is weight over volume. So specific weight will be what? W over V, which is weight over volume. What's our weight? Is 7. And what's our volume? 0.001. And that will be equal to 7,000 Newton per meter square. Per meter cube rather. because it's volume. So that's for the what? Specific weight. Now we go to density. Density. So what's the density? You can calculate. Remember from this formula, we only have specific weight, and we also have volume. Then we also have what again? The specific weight that we just calculated. So we cannot use any of this. We cannot say mass even though we have volume, we don't have mass. So we can use this formula instead. We can use weight over gravity. So since we already have weight here and we know our gravity, so it will just be, what's our weight? 7. Our specific weight, 9.81. So and that will give us 713.5 kilogram per meter cube. Remember it's density, so it's mass over volume. This is mass, this is volume. So lastly, for the wetness now, we have calculated for this, Now for specific gravity. What specific gravity? That's, remember we said it is density of substance over density of water. So specific gravity is equals to density of substance over density of water. So remember that we got our density of the substance here. So just insert it to be 713.5. Then over density of water. We know that one is 1000. Density of water is 1000 kilogram meter cube. So you just put 1000 there. And what would be our answer? That would be 0.7135. Note that specific gravity doesn't have volume limit as it implies. So that's for the first question. Let's solve this second question. We have to calculate density, specific weight, and weight. Then we are given volume and we are given specific gravity. Let's write out the given. What were we given? We are given volume of 1 liter, which is equal to 0.001 meter cube. Then we are also given specific gravity of 0.7. So now, the normal formula for density is supposed to be what? Mass over volume. So here now, but we don't have any mass, or though we have volume, but we don't have mass. So we have to use another formula. So look for density now. Density will be Sg multiplied by 1000. What is this 1000? It is the density of water. So let's just say to get the density. So S times 1000. That's it. So Sg, that's specific gravity, multiplied by 1000. What is specific gravity? Our specific gravity is 0.7 times 1000. So, and that will be 700 kilogram per meter cube. So that's for the density. So the next one is specific weight. So how do you get specific weight? We already have the density and we know our gravity. The specific weight is density multiplied by gravity. So since we know our density to be this and we know our gravity to be 9.81, and just start and say 700 multiplied by 9.81. So that would be 6,867 Newton per meter cube. Yes, Newton per meter cube. Remember, if you are calculating for specific weight, it's supposed to be weight over volume. That's why it is Newton per meter cube. This is the meter cube, this is the Newton. So for the last one, specific gravity. How do we do for specific gravity that you asked for? Specific weight and weight rather. I'm looking for weight now. So since specific gravity is equals to weight over volume, we can get weight from here. So specific gravity is equals to, since 6 specific weight is equals to weight over volume. Just say that bring this specific volume here. So can just insert the information like that. Let's use it like that. So this is 6,867 is equals to is the weight we are looking for. Then the our volume is what? 0.001. So like that, W will be this multiplied by this 6,867 multiplied by 0.001. And what will be our answer? It will be 6.867. So this is just the first part of it. We have gotten our density to be 700. We have gotten our specific weight to be this. We have gotten our weight to be this. So this is just the first part of this introduction. We are going to be doing the one that has to do with dynamic viscosity and pneumatic viscosity. Then for the second part, then for the third part, we are going to begin for pressures of the fluid. So thanks for watching. Help us subscribe, help us like, help us share.